GATE 2012 Civil Engineering Question 45. The following data are related to a horizontal curved portion of a two-lane highway. Length of the curve is 200 meters, radius of curve 300 meters and width of pavement 7.5 meters. In order to provide a stopping side distance SST of 80 meters, the setback distance in meters required from the center line of the inner lane of the pavement is. The four options given are A 2.54, B 4.55, C 7.10 and D 7.96. The relevant NPTEL reference has been cited. So coming to the useful data, setback distance is used to provide adequate side distance at horizontal curves. So if we assume a road which is on a horizontal curve, and then let us assume this is the center line of the road. So if there is an obstruction somewhere here, it will block the side distance of the car moving on the road. So it won't be able to see who is coming from this end. So in order to prevent that, what is done is there should be a minimum distance provided from the center line of the road, that is called the setback distance. So let us assume that the radius is r, which is measured from the center line of the road. Let us assume this distance, that is the center line of the road to the inner boundary of the road, is d. Let us call this angle as alpha by 2 and this angle is alpha by 2. So the setback distance, that is m, will be given by m equals r minus, where this distance is r and this distance is r minus d into cos of alpha by 2. So setback distance m would be given by r minus d cos alpha by 2. This is usually done when the road is multi-lane. In case the road is single lane road, so d would turn out to be 0. So setback distance for a single lane road would be r minus r cos alpha by 2. So it is given that the length of the curve is greater than SST. Here the length of the curve has been mentioned as 200 meters and the SST is 80 meters. So in that case the formula discussed in the previous slide is applicable. So LC is greater than SST. So setback distance would be given by r minus d cos of alpha by 2. So alpha by 2 is given as 180 into side distance by 2 pi into r minus d. Here d would be equal to the width of the pavement by 4. So the width of the pavement has been given as 7.5 by 4, that would be the value of d. This would become 1.875 meters. So substituting the values here, 180 into side distance, that is 80 by 2 pi into 300 minus 1.875. So this would turn out to be 7.69 degrees. So substituting the value in the relation of setback distance, that is r minus d cos of alpha by 2. So r is mentioned as 300 meters minus 300 minus 1.875 into cos of 7.69 degrees. So this would become 300 minus 295.44. This would become 4.55 meters. But the setback distance needs to be found from the inner lane. So that would be equal to m minus d, that is the effective setback distance. This would be equal to 4.55 minus 7.5 over 4. So this would become 2.675 meters. So the setback distance needed to provide from the center line of the inner lane of the pavement is 2.675 meters. None of the options matched in this question and marks were awarded to all. The relevant NPTEL reference has been listed.